Codefresh peeps.
All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's February 10th, 2021. My name is Eric Osterman, and I'm going to be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your teams and showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to our YouTube channel, as well as follow up with an email so you can share that with your team. So with that said, let's kick it off. Tons of announcements today. One is Cloud Posse has released our SSO module. So you can go to github.com/terraform-aws-sso. Many thanks to Mohammed for bringing it to our attention that these features were merged into the Terraform provider. It's been requested by all of our customers, so we are adding support for this. This is a module which has no root module, actually. All the modules are submodules, one for the account assignments and permission sets. Matt Calhoun on our team set this up, and we're starting to roll this out as we go. Seems to work pretty well so far. There's still some ClickOps with getting, I guess, the initial SSO set up, but the day-to-day management, day two ops can all be done with Terraform.
Yeah, I think the quick distinction there is configuring your IDP and turning on SSO and integrating it with your IDP is still manual ClickOps. There are no resources available or API available to do that. And then after that, managing all the permission sets and the assignment of permission sets to accounts can all be done with our modules at that point. So that's sort of the line of delineation
Yeah,
between
that's helpful. So it's not a
automated and
Terraform
non-automated.
limitation. It's an AWS API limitation.
Yeah, exactly.
The other good news is we have merged the pull request, which documents the first batch of AWS components that we have. Components for us are root modules. These we have root modules for multi-account AWS architecture, account settings, cloud trails, Datadog monitors, DNS primary and delegated records. We got EKS, EFS, SSO. This is actually the SAML SSO, not the SSO we just released. So to make that distinction, our state backend. We got a dozen more modules or components coming out in the coming weeks.
Anybody lose Eric?
You guys hear me?
Yeah, I can hear you
Yep.
fine.
All right, cool.
Yep.
Yeah, so we got dozens more components coming out. They'll be documented as well. You go into any one of these component settings, and it gives you, the usage. Now, this is the usage how we use things, right? We have this YAML stack configuration. So you would just drop something like this in your stack configuration to set up your multi-account architecture, complete with support for organizational units and all that jazz, and service control policies.
It's probably just worth really quickly calling out that you then use the Atmos CLI tool to parse
Yeah,
that stack config and turn it into regular Terraform vars at that point.
yeah, we got options as
Yeah.
we've been alluding to. So we have the geodesic. We have Atmos. Atmos is our CLI that we use. It's distributed as a binary, or you can run it yourself. And this is like our recommended layout of a project where you have all your stack configurations, then all your components. And the key here is to separate configuration from business logic. And that's what we have here. And I'm actually going to cover this as part of one of the questions that was brought up in our Terraform channel. So I won't go too deep in it right now.
Sorry for jumping the gun.
Yeah, no, there's that. But yeah, okay, I'm gonna control myself too because I get excited about talking about these things. All right, next thing is a work in progress, nothing yet to show. Matt Calhoun's working on the AWS Firewall-manager Terraform module, which will slot into the solution as well as everything else that we have. I'd expect that to be released in the next 7 days or so. Our Cloud Posse docs have been really out of date. Now they're not so much out of date as there's just not as much stuff there. We have taken a move of deprecating basically everything we had there, which was dangerously out of date and sending people off, off a cliff. I didn't want to do that anymore. We're reorganizing the documentation now into these major categories, and we're going to start with a simple approach of documenting how to get your first stack set up using Cloud Posse modules and our strategy. That'll be a tutorial. We'll have how-tos, which kind of take you beyond there and show you how to operate this on a day-to-day basis. Reference examples, some of our best practices, and introduction to all of our concepts, stuff like that. Like, what are our core concepts? What's the terminology we use? What is our philosophy? Stuff like that is going to be coming out here very shortly. Matt Gowie is helping us starting to write some of this stuff. So stay tuned because I feel so bad. Everybody's been asking lately in Slack, like, how do we do this? How do we do that? And I've just been teasing the carrot, but not providing anything. I hope this documentation will be out shortly for some of the early adopters out there. Any questions on that? All right. So we haven't talked as much lately about codefresh. We still are big proponents of codefresh. We do use a lot of GitHub Actions as well. One of the drawbacks using codefresh, so codefresh is a so to say cloud native, Kubernetes native CICD solution. It's a SaaS, but also available as a hybrid or on-prem solution. One of the problems with codefresh is something we take for granted if you've been using perhaps Jenkins or GitHub Actions, is the ability where you like create a net new repository and you just add some workflows and voila, it's just running. You don't get that with codefresh. You got to go log in to set up those workflows or pipelines, or you have to automate it somehow using their API. So we have released our GitHub action that solves this problem and works really well. So here's the GitHub action repository for it. The way you use it is pretty easy. All you do in your microservice repo, for example, is drop this GitHub workflow file in there. And this GitHub workflow will then use your organizational secrets for codefresh and provision the pipelines that are centrally hosted in a repository. For this example, we're pointing to Cloud Posse's pipelines. But this is a really powerful strategy because what we started with when doing release engineering was kind of like the original holy grail from last year forward or last year backward was kind of like, at a minimum, you should be able to have your pipeline workflows in the service. So what if you have 100 services or 50 services and all of them are kind of similar? Now you have the same pipelines in all of those repos, and you might have minute differences in each one of these, and management of that is a nightmare. Plus, it puts the onus on developers to have an opinion on how to write their pipelines and all of that. From a maintenance perspective, I don't recommend it. So our strategy, for example, with CodeFresh is to define categories of applications that your organization supports, microservices, spas, backend services, stuff like that. And here we go with a microservice. So here's like a reference implementation of the pipelines we would deploy for a customer that wants to deploy a microservice. So the cool thing with this is all these pipelines can be versioned and shared and templated. And then you use our codefresh GitHub action here, which will install version 0.1.0 of the pipelines here, configure it as a microservice, take these pipelines, in case you didn't want to have all of them, and install them. Plus, you can run this on a nightly schedule, so you avoid configuration drift. Or if you didn't pin to a version, you can pin to master, and then you get the pipelines updated in all of your repos. So different ways of doing that. We're following a similar pattern now with GitHub Actions, so you can syndicate your GitHub workflows across repos. We're doing that as well with a similar action called under Actions here, like GitHub. We're calling this one CRUD. This one's a lot simpler, and we want to extend it, but it has the same general concept where you can centralize your GitHub action workflows and distribute those throughout your organization. Any questions on that?
Yeah.
Yeah. Oh, hey, go for it, Matteo.
First, thank you for all your work, because you cannot imagine how you are helping this single DevOps in the company. Really, thank you. And sorry for my ignorance, but is CodeFresh something that you developed?
No, so CodeFresh is a SaaS. It's by a third party, codefresh.com.
Is it something, Jenkins X?
Yeah, it's an alternative. It's in the same category of that. Like the number of CI/CD platforms out there, I can't keep track of anymore. There's probably 50 products at a minimum, 100 products possibly in the category. Many are open source. Most are SaaS solutions. You got BuildKite, CodeFresh, GitLab pipelines and GitHub Actions, and Circle CI obviously has been around forever. Travis CI, etc. Those are all in a similar category. Spinnaker. Well, yeah, exactly. It's in the category. It's in the broader category. Then you have a subcategory, a specialization of continuous delivery. So Spinnaker is in the continuous delivery category, along with Harness, along with Argo CD, along with Weavework Flux and others, Go CD, etc.
So anyway, CodeFresh is the one that you would advise, because I'm looking for actually.
So when we got started, 4 or 5 years ago, I felt like the mature SaaS offerings for this were few and far between. Circle CI wasn't where it is today. We still recommend CodeFresh regularly to our customers. It's been good for us. The differences between CodeFresh and GitHub Actions, are arguably diminishing. CodeFresh, I would say, still has a better developer UX and visualization options, and has a lot of excellent documentation for how to get up and running and provide support. While if you go with like the GitHub Actions approach or some of the other things, you're going to be left, figuring out yourself. Some providers like, Spinnaker, there's Armory, a commercial backer behind it offering support. But I don't know if you'd get the same level of support, if you just picked up Argo CD. Like, you're not going to get commercial support for that.
Yeah, thank you.
When you mentioned Jenkins, back when you started talking about this, were you talking about I think it's the GitHub plugin, right? That you can set it up to scan an entire repository for Jenkins, or an entire organization for Jenkins files. Is that what you're talking about?
Yeah, that's what I was thinking of when I said that.
I gotcha.
So it's not built into Jenkins. It is
of note is that capability is only available for GitHub.
Oh,
no other CVS. Yeah. There's only the GitHub plugin does that.
Well, everyone who doesn't use GitHub is a contrarian, so I guess that's cool. Joking. Yeah. All right. Any other questions on that topic?
Yeah. Okay. So I'm sorry, please. Let me just ask real quick. Okay. So I just got a tax right now to actually use just AWS to do this whole CICD thing. I have used Jenkins in the past to do
Yeah.
it, and I've been trying to get my head around. Yeah, I saw some docs on how to just use code pipeline, code build, and check out, because I'm going to be using I'm still going to be using GitHub, not the AWS rendered service integration and all of that. So it's kind of blurry. Like, how do I rearrange my whole Terraform to fit into this? And the company is like, I want AWS. We want to go serverless. And I'm like, oh God.
Yeah. I might not be, I'm going to give a colored response to this. Like, I'm not a fan of the AWS CI/CD solution. So that's going to influence the way I answer this. Basically, what's nice about AWS CI/CD technologies, code build, code pipeline, code deploy, etc., is that there's really good IAC coverage for using them, and you can fit all of it together under one technology, one tool, Terraform, and run with it. But if you've used some of the other quote unquote modern CI/CD platforms out there, the developer experience is night and day difference and better with them. So I wouldn't like, AWS code commit, like I wouldn't touch it with a 10-foot pole. If you use it if you have to have like backups of GitHub somewhere for a compliance requirement or something, but don't use it as your primary source control system.
Oh no, I'm not going to use Go Copy. I'm going to be using GitHub, so I'll just connect my GitHub to pipeline.
So when you go to Cloud Posse's GitHub, we will have modules and examples for how you can implement some of this stuff, but these are mostly maintained by our community and people who use them. We, as a company, use predominantly GitHub Actions or codefresh. Yeah. Anybody else have something more to add? Anybody I'd love to hear anybody a big fan actually of code build, code pipeline, and using it for everything.
I'm not going to call myself a big fan, but I have enjoyed using it recently for a project that's using ECS. And so the integration point is actually a push from GitHub. So code build looks for, it's connected to a webhook in GitHub. You push the repo, it triggers code build builds the image and stores it in ECR. That triggers a code pipeline, which triggers a code deploy, which does a blue-green deployment on an ECS cluster. And it's pretty slick. I mean, it just works kind of out of the box. And I should say out of the box is relative because it took a lot of Terraform to get it there. But after that was in place, it's pretty straightforward. I wouldn't want to do what all that stuff is doing in a GitHub action or in a Circle CI or something like that. I bet you can. I'm sure you can, but I wouldn't want to do it.
So if we're talking about that workflow, the Cloud Posse Terraform AWS ECS web app will string that together for you. What my challenge is with some of this stuff is that, and this is not a problem unique to ECS, and I see people or companies do this with Kubernetes as well, is that the simplified look at continuous delivery is you're taking this image and moving it through a pipeline so that it ultimately goes through QA, UAT, staging, whatever, production. And if that works, that's great. But in reality, like when we deploy a new image, there's often a lot of other things that have to go along with it. Maybe it takes some new settings. Maybe it needs new configuration things for different environments. So deploying a container independent of its configuration and settings, I think is a oversimplification of the CI/CD process that a lot of companies need. For example, a common pattern in Kubernetes is, well, you'll push a new image to the repository, and then the cluster's looking for a new version of that image and then reloads it. But what if you need new config maps? What if the properties changed in the config maps? There are new secrets, all these other things. I don't see it working as a generalized pattern in the long run.
Yeah, you have to do database migrations.
You have to run database migrations.
Yeah, that's the hard part.
Yeah.
Yeah, has
Yeah,
anyone ever, has anyone used
Aquabase,
AWS
maybe.
Copilot? Sorry.
Say that one more time.
Has anyone used this
yeah,
AWS Copilot to
Oh,
use this?
yeah. I think I did. Yeah, guys, can you hear me?
yeah, Mohammed, was it?
Yeah, yeah,
Yeah,
yeah.
yeah. Do you
Me.
want to share your experience with that?
Yeah, I use it actually the code star family. So like code build, code deploy, and code pipeline for ECS blue green deployment. Like Michael said, only addition was cross account rules. So AWS is over abstract these, the pipeline here. If you need something like Eric said, like a more customization for your pipeline, you need something like codefresh or action or whatever CICD nowadays. But the AWS tools is way abstracted, more simpler, but it like hard to customize for your own needs. It's work pretty out of the box if you use something like this repo, the ECS web app. I think it's already there, but again, I'm thinking from my opinion is that changing your CI/CD is bad for you. So stick with something, even with Jenkins. If Jenkins work with you, stick with Jenkins. Don't change it because it's like moving from Terraform to CloudFormation. So that's bad. Yeah, that's my
Yeah,
opinion.
there's something to be said. There's like using the CI or CD platform that your engineering team wants to use and is comfortable with and will empower them, and not. This is a bad decision to come top down. If nobody in the organization has an opinion, like you are strategically choosing code build, code pipeline because this is what your engineering team really wants to use, versus Circle CI, codefresh, GitHub
And
Actions.
GitHub Actions has a pretty big community. Like you can offload a lot of work to that community. There are so many actions that can save so much dev time and operations time. That's a big drop. That said, AWS also has an official GitHub action for running a code build job, I guess, step something. And I've been using that because you can get code build machines up to 200 something gigs of RAM. And that's perfect for like really high parallelism job or very intense work. You are double build, so you're build for both the GitHub Actions time and the code build time, but it's way easier than, for example, setting self-hosted GitHub Actions runners.
Yeah.
And just getting a code build up and running if you need something very powerful is an awesome workflow. Yeah, it should be somewhere in there.
I'm glad you brought that up because we've been using like the ECR login and the configure AWS credentials, GitHub action tasks. So this is a good resource if you want to use some of those. I'll share that in the channel.
Oh, thank you, because I was already saying you could share that.
Yeah. All right, let's see here. So let's move on. Get to another topic here. This says more about me, maybe. I don't know. I missed the announcement. I was really excited when I heard in sweetops this week that back in December, support in the AWS provider for refresh policy on autoscale groups is now supported. This has been a real pain using autoscale groups in Terraform because this was not supported. So there were other hacks that came out. Some people were even using Terraform to call CloudFormation to create their autoscale groups. I guess that is less required now. I haven't checked this out personally, but that's cool. Just 5 minutes before office hours today or something, Terraform, one more alpha of Terraform 0.15 dropped. I'm guessing that's imminent now that a 0.15 release will come. Just a reminder that 0.15 should hopefully be the last release of the 0x series for Terraform, after which they'll move to 1.0. That is the rumor, at least.
Hey Eric, can you tell a little bit more about the instances refresh on ASG? What was that feature about?
Yeah, so what would happen is you would deploy a new launch configuration, for example, for the auto scale group, and nothing would happen. It was just crickets. So now with the refresh policy, it should work more and more like the way that auto scale groups got refreshed under CloudFormation, so that it keeps both groups online and starts draining one while hydrating the other, is my understanding. Somebody else have more hands-on experience with it? I was just reading the announcement. Matt?
Yeah, that's actually exactly how it works. Before that, what you would have to do is essentially like scale your auto scaling group up to twice the size of what it was before, and then scale it back. So if you had 3 nodes, you would have to scale it up to 6. It would build 3 new nodes with the new policy, and then you would scale it back to 3, and then it would kill off the first 3 nodes that had been there the longest, and then that's how you would update these things. Now with this new feature, it basically just takes care of that auto scaling and draining like automatically when you apply the new policy, which is great. It makes your
So,
life simpler.
so does it create another ASG, or does it
No,
refresh the one ASG?
so classic example is like, let's just say you're using like a T2 Nano, and now you want to move to like, whatever, an M1 or something like that. So all it does is you say, I want 3 of these things. So what it will do is it will scale your existing ASG to basically twice the size of what it is. And it will spin up your new versions of whatever you've specified in there. And then it will spin down the old ones, all while, keeping your services up and running just like the ASG would normally do. So it basically just gives you whatever your desired state is without you having to do anything except specify the new policy.
So if somebody wants to
All
add
right.
that to our module here, that'd be awesome. I'll share it because it looks like it hasn't been contributed.
Are there different types of policy? Just scaling by 2 is
No, there's
now
a
the
it was
refreshing?
percentage based. It looked like from what I
Oh, that would be nice.
yeah. So so min healthy percentage. Yeah, so you can say like so you set a really high percentage there if you want a very slow rollout.
Yeah.
And the old policies still exist, like the oldest one, or there were multiple policy for
Right, like
old
whether it's
refreshing
the
ASG.
oldest or the newest.
Yeah.
I don't know.
Yeah. No worries. I will
Yeah.
read the announcement.
Yeah,
Yeah, thanks.
I don't think it.
Yeah.
I don't think it retains the policy. I think basically once you update the policy to the new policy, it just keeps working to try to get you to that new desired state.
If somebody could remind me real quick, which Terraform version does this come into play?
Well, this would be a provider thing. So this is in the Terraform AWS provider. Let's see. This was released in
Last year.
3.4 something, right?
I mean, so it's definitely in whatever one. So it was released in 3.22.
Okay. I was also wondering if there were like any limitations to just commercial AWS, but I'm pretty sure it should work for all of it. I guess we'll find out.
Yeah.
Yeah, about the policy, it do actually replace all the instances, so it do not really work with policy there. So all your fleet under that outscaling group will be replaced.
Okay.
Yeah, randomly then. Yeah.
It depends on what your policy is, but usually it's oldest first is the termination policy or what in your scaling policy. That's the default. So whatever the longest
termination policy still exists for the refreshing feature. Okay.
Yeah, it does, but all the fleet will be replaced, so it's not going to keep any of the old ones or the newer ones.
Right. Yeah. I guess depending on what you change in that policy, yes.
Cool. And I just shared the link to the discussion on GitHub for that, so you can check out the details. The other thing was 14.6 just dropped, 0.14.6 of Terraform. which notably added support for single sign-on cache credentials and otherwise some bug fixes there. The last announcement, or two more announcements. Self promotion here. If you haven't already gone to youtube.com/c/cloudposse, I invite you to subscribe to our channel where we publish all of our office hours, so you can catch up on past episodes. And the last thing is we are also hiring Terraform developers as 1099 US contractors. If you are a senior Terraform developer, please do reach out, and we look forward to talking with you. Let's get to some of our talking points. First one was Macon. You called out an interesting post by Codefresh, emphasizing a post where Codefresh talks about some anti-patterns for Kubernetes. Let me open up Slack here so that everyone sees the. I did that. All right. So, Macon, you say you guys have maybe already discussed this before, but what do you guys think about this blog post by Codefresh discussing some of the Kubernetes anti-patterns, specifically the fourth point about mixing application deployment with infrastructure deployment? And he's facing similar concern with ECS, where adding two workflows, one in GitHub Actions for building and deploying the app, and the other for app-specific infrastructure like ECR, ECR task definitions, and so forth. And my issue is how do we improve this to deal with the various race conditions as such? So yeah, let me talk about this. Those of you who have tuned in before have heard me bring this up a lot. I call it the 4 layers of infrastructure. It's critical to how we think about things, and try and make this a little bit bigger here. The gist of it is these are our 4 layers of broad strokes of infrastructure. You got your foundational infrastructure, your AWS accounts, your VPCs, your IAM architecture, DNS architecture as such. That is its own layer. That has its own software development lifecycle. You don't tear down everything from layer 4 all the way back up to layer 1 again. Like, you're operating a platform that's online all the time for different teams and different divisions. So then on top of that, you're laying down your platform. That's the next layer. Your EKS clusters, your ECS Fargate clusters, backing services required by those things. That's the next thing that happens. That has its own life cycle, also changes relatively infrequently. From there, you roll out your shared services. These are things like maybe Jenkins or your GitHub Action Runners, your Datadog monitoring integrations, stuff like that. And finally, you get to your applications, which is the final layer in our paradigm here. Well, you can maybe talk about security and stuff.
Just one new question about this field. You mentioned about layers. That's perfect. So every layer, I suppose, is a Terraform deployment?
Possibly. It depends on your tool chain. This is more conceptual.
Yeah, but if it is if you have 2 layers that are 2 different Terraform, are you going with data? So basically, you're fetching back from the other.
Yeah.
Or you are importing, or
yeah. So it's really important in Terraform that you create smaller and smaller root modules that do one thing really well. And that life cycle is disconnected from the others. It's optimizing for what we call like day 2 operations, as opposed to like day 0, day 1, where you're just bringing everything up. The cold start, I think, misleads a lot of developers getting started with this. This is controversial, possibly. Maybe some people are doing this. But like, optimizing for the cold start is one problem that is different from optimizing from day 2 operations. And what makes cold start very easy can make day 2 operations very hard, vice versa. So in this picture here, you'll have different tools. Like, for example, your foundational infrastructure. Maybe you're a massive enterprise. This is way outside your division. They're using AWS Control Tower. Cool, whatever floats their boat. Not our choice. But that's one tool. That's one way to do the foundational infrastructure. But just because you're using that doesn't mean you have to continue using AWS like CloudFormation. Platform, you might be using Terraform. So you could be terraforming everything at the platform layer. And for shared services, now maybe you're using Kubernetes for most of that. So you're using Argo CD for most of your continuous delivery there, for example. And then your applications. Well, now, okay, so this team, they like using CDK. This team uses serverless. This team uses, straight up Kubernetes. There's a lot more tooling maybe that's used at the final layer for how your applications are deployed, depending on how they're written. For example, deploying your applications, you're probably using Circle CI, codefresh, GitHub Actions. But for foundational infrastructure and platform, you're probably using what we're calling now tacos, Terraform automation collaboration software. This is like Terraform Cloud, Spacelift, Scalar, and Zero. There are all these platforms out there that make Terraform automation in a team environment hospitable.
Okay.
So to answer your question about this ECR thing, at a minimum, ECR should be out of phase with CI/CD of your applications. Meaning that when you set up, you have a net new application, that application ultimately needs a artifact storage, in this case maybe for Docker. So you provision an ECR for that. And you might totally tear down your application, but because you tear down your application, do you want to tear down every image you've previously built for that application? No. Especially from a compliance standpoint, you're going to want that to persist. So that's why these two things are decoupled. And that means that the phase at which you deploy ECR is different. Then, yeah.
It's Michael here. So I got a question. Where you would put the ECR provisioning in these layers?
So that would probably be therefore considered in this structure as like in the shared services part. And so ECR exists, pre your applications getting deployed. Look, these things can be updated all the time. It's just that like you don't tear down beyond one of these layers at once, for example.
Yeah,
I would maybe use a different.
I was just going to say I agree with that.
Sorry,
my
Andy,
bad. Sorry to step over you.
No, that's cool.
No, I was going to say, yeah, in my case, there's layers. I think we talked about it last week or week before, the concept of stacks. So there's like, VPC stack, non-prod and prod. And then on top of that, there's maybe like an SSL stack for certificates. And then on top of that, there's, ECR beside it, the ECR stack. And then on top of all that stuff sits the actual projects that write to the repositories, and those come and go, but they don't destroy the ECR repository when they go away. The repository stays there.
Yeah. That's congruent, kind of slightly different terminology than we use, but same semantics. Andrew, what were you saying?
I'm gonna reword Makon's question a little bit, and I think
okay.
To make it a little bit more clear. You have infrastructure that you need to create that is only for the application. Go back to your layer picture. Your backend API needs a database, and you're going to deploy RDS. Where does that Terraform code live? I would say it lives way up there, still in layer 4. Like you don't deploy an RDS database for your backend API up in the layer 1 or whatever. That doesn't make much sense.
Exactly.
Yeah, and it goes in my case, it goes the same for the ECR and the task definition, because this application only related service. So we only have one ECR per service or per application. We don't use shared ones. So I think we mix a little bit your layers there.
And
it's just
also one of my frustrations working with ECS, just to say that, like, what I really love about Kubernetes is you can just very easily produce this YAML manifest that describes the architecture of your application and ship that together with your Docker image, and voila, it's easy to deploy. While with ECS, everything is like moving infrastructure, moving mountains, and you gotta whip out the Terraform just to deploy a new ECS task. And it does complicate application rollouts in my mind. And that's why I think people who use ECS very frequently are more concerned with just updating the Docker image and less concerned with how do we update the Docker image in phase with updating the ECS task configuration as well. I talked over some of there briefly. Was that you, Andrew?
Nope, I'm good.
Okay.
I think it's an interesting thought experiment to, because when it's infrastructure, it's a little bit more cut and dried. But like in a Kubernetes world, I think it's interesting to think about, like, does the ingress resource belong being deployed next to your application? Does the certificate resource belong being deployed next to your application? Or should they be separately lifecycled too?
Yeah, it does open up some of those questions. I don't think there's a black and white. For us, we tend to deploy the ingress together with our apps because how well ingresses work in Kubernetes is just pretty awesome that an app can be responsible for its own routing. But maybe in a larger organization or larger context, that's a big liability that an app can hijack a route. So then that needs to be more centrally controlled.
Yeah, I think there's people tend to give more responsibility to developers, as they know what they're doing and they should be responsible for the application. And I've seen more and more people giving the permissions to deploy what they want on Kubernetes and take responsibility for that.
Yeah.
This goes also for monitoring as well, because the infrastructure team don't know the internals of the monitoring of the application. And if they can provide that, the development team, then it's great, at least in my opinion.
That's a good point, but I can give you a counter argument that I cannot tell you the number of times I have discovered a development team with, less DevOps Kubernetes chops, than my DevSecOps team has, that are putting an ingress in front of their Postgres database, or offering something with only HTTP, no certificate, no to TLS or whatever, doing things that are terribly bad practices because they just don't know.
I think it has to be complemented with policies, like programmatic policies, and that's how you can scale it out, maybe. And those policies, by the way, are up to you to write as an exercise because nobody's giving them away.
Yep.
Yeah, we try to do that with policies and modules as well. So the developers can just use something that is pre-baked and with some best practices in that.
Yeah. So the next topic I just wanted to cover was kind of one of the things I was alluding to during the announcements. I didn't want to talk too much about, but a common request that comes up, and I'm just going to talk a little bit about it, and then we'll get to other questions, which was, anybody have any experience or recommendations for how to keep your Terraform code dry? TerraGrunt has a very specific, well-documented approach for how to do that. It's arguably not compatible with Terraform Cloud, at least wholeheartedly. Something still would have to control it if you want to use Terraform Cloud for that. Scalar and Spacelift, and M0 does have support for it. There's other solutions that have come up here. Somebody else suggested like the TerraSpace framework, also a nice documented solution. And we are working on our own strategy that we've been using for the last year and a half and evolved considerably in that time for keeping things dry. I think the important thing to think about when you're writing Terraform to keep things dry is that Terraform is a infrastructure as code, configuration language as such. But even then, there's two different ways of looking at it. There's like, this is how we want to configure EKS, and these are the settings when we deploy EKS we want to use. And factoring those two things out is important. And when you do that effectively, what you get are what we're calling these root modules here, these Terraform AWS components. And these define the business logic, the opinionated business logic for how we want to do EKS. And those modules in the end use other modules like our EKS cluster. But how do we do the last mile integration? And that's what your root modules are. And that's what your job in your company is, to come up with a library of root modules that are used interchangeably as needed. So that's why what we came up with for Cloud Posse is this concept of a stack, which is different than the way it was described just earlier. For us, a stack is everything that comprises your environment. So, and that environment is comprised of components. So an example here, we post a highly, this is the way things would get organized in a very dry fashion. So here's just our core business logic for how to do these, to have these capabilities. And then the configuration is in these stacks here. So a stack configuration for us looks something like this. So we have a VPC, we have EKS, we have, load balancers and ACM certificates and DNS and all of that stuff comprises this. And when we want to come up with a parallel environment, we just copy that file. Another cool thing that we have support for is this to keep things dry. It's called imports. So it's just YAML. So we can just do deep merging of these YAML configurations. So you can come up with a single configuration that represents what it means to have your application. And then you can just import that as many times as you need to import it in your different stack configurations, and your configurations get very dry. Unfortunately, I don't have more to show you in the form of documentation here. This is what we are actively now working on over the next few weeks to document how to get started using Atmos, how to get started using our components, and we'll be publishing stuff up also to our reference architectures repo.
Hey, Eric. Pepe.
Hey, Pepe.
But every stack, every component could have its own state file.
Yeah, so we're not opinionated as it comes down to that. That's ultimately how you want to architect things. We have an opinion on how we architect the state and do that stuff, but it's agnostic to using the stack configuration here.
Okay, cool. Thanks.
Yeah, I think it's probably, would say our recommendation is that the state file should be broken down to something much smaller than the entire stack. So like each component in the stack should have its own state file, like nothing much larger than that, just for safety reasons.
I think I misinterpreted Pepe's question as thinking of state backend. But yeah, so every single component has its own state for every single environment or stage, or whatever your internal terminology is for that. We use the word stage. So there's a state for EKS in prod. There's a state for EKS in staging. And going back to like this cold start problem we were talking about earlier, is like when you optimize for day 2 operations, you actually end up with quite, at least in our experience, you end up with quite a lot of components. Now, if you want to optimize for day 0 operations, or like day 1, like getting up and running fast, stick these in one component. Great. But now you have this massive state combined with everything. The blast radius is huge. Terraform figures out what needs to happen for you, but it's risky. So when you optimize for day 2, you end up like, here you see we have ECR. We consider that its own component that we don't complicate with like an application.
There's something that I'd like to add to that. We've been using that technique for a couple of years now, and just want to point out, any kind of splitting of state like that always has its pros and cons. It has a lot of nice advantages in that, as you say, you're breaking down the problem into smaller pieces. So for instance, we use it to split the management of cluster versus application deployments, right? So we have, say, one cluster can host multiple applications, maybe a test application or test version of the application, a staging and whatever, right? You get the idea. So the cluster itself is one Terraform state, and then each deployment of the app is another. That's nice. It works really well. The only thing you have to be aware of when you make that transition is that it becomes easier to break things between those different states, right? For instance, and maybe it's just the way we're doing it, but if you want to have multiple states like that, you'll end up using remote states in those applications, right? Because the test application deployment will need to know what VPC it's in and what's the cluster name and blah, 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 things like that. So it'll use remote state, the Terraform remote state of the base layer. Maybe that would be the top swim lane in your diagram earlier, right? If you make a change in that base layer, you don't know, you have to bear in mind that there's other states now that depend on that, right? If you change the output, you rename an output, you forget, that you've renamed it and that there was something using it. Now, next time you run the Terraform apply in your application, it's going to say, hey, that output doesn't exist anymore, and you've broken something. So it's just that I just wanted to point out that there's that little.
I love that you pointed that out. And that's a reality of doing this, and you decouple things, which introduces two problems. So one is you need a way to access remote state conveniently, and Terraform makes that relatively easy. You have the remote state data source, which we have abstracted away into this module called remote state, which fits into our opinionated way of dealing and organizing with things. So we have our Terraform YAML stack config. So this is how we handle now dealing with remote state very easily. We can just say, hey, give me the remote state of our EKS component for my current context. So we instantiate the state based on our current context and pass it here. I think this is slightly out of date, maybe. No, we don't use context because we want to specify which stack we want to get it relative to. Anyways, my point with this was leading up to the next thing is great. So remote state solves how we pass information, but it doesn't solve how we do the triggers. Like, how do we automate when this thing updates, this other thing updates, especially in a decentralized team environment. And what we're talking about here conceptually is a policy. We want a policy that when our dependent modules change, we are updated. Because now suddenly there's things our Terraform module depends on which are not in Git. They're in some state somewhere. So this is where the tacos providers come in. Things like Terraform Cloud, Spacelift, N0 Scalar have ways of doing policies so that when your dependent things change, you can do it. And this is part of the crux of the problem when you're trying to do Terraform on roll your own, GitHub Actions, Jenkins, whatever. It's really hard to do and why I don't recommend it.
I want to add something, Eric. So
yeah, go ahead, Mohan.
Yeah, this is like a best practice. I was using remote state most of the time, and the point that Oliver said is so true. So my advice, guys, is that use data sources more than use remote state. With each Terraform AWS provider release, there is a new data source introduced. So let's say you want to have the RDS endpoint. Okay, you would use a remote state for your databases stack and get the RDS endpoint. But with the data source for RDS itself, you can call it from AWS itself. So you can query whatever on AWS with the data source. That will make it easier for you in case you update your RDS database. You don't need to worry about the output or remaining the output, because on all of these remote state, you need to manage your outputs. But if you use the data source, you don't need to.
That's a good point.
So, it is, although it definitely dovetails to needing a very sophisticated tagging system, especially in large environments, to make sure that you can do those queries and tie all those things together and identify using data source queries the things that you actually want to look for, which in and of itself can be almost as complex as managing the the remote state at some point. I've managed some very large environments previously that it was very difficult to use data sources, and that's why we ended up using remote state in a lot of places, because remote state was coming from a known path that we could just point to, versus like, how do we query for this, like
There's
in the whole universe.
there's a lot of other extraneous data you can put as well in the output of remote state, which might not be available if you're just using a straight up data source. So like discovering the VPC, yeah, that's a pretty good example. Just use a data source for that. But if you need some arbitrary account metadata that's available when you're provisioning the AWS accounts, but not available through tags or other things, you need to stick that somewhere, then that's a good place for it.
Like a database password would be a good example of that. Because once it's in RDS, you can't get it out. You can change it, but you can't get it out.
I think that's a really bad example of that.
That's a touch. That is a bad example of when it's used. I mean, like the reality is that password is in the Terraform remote state, but shh, don't tell anybody.
Yeah. Or don't use that. Like change your root password immediately as soon as you provision an RDS cluster, and don't do it through Terraform.
Yeah. All right, so we are almost out of time for today. Let's see the office hours channel here. I'm gonna take a look to see if any other questions were posted here.
I think that's
260 unread messages. Those are rookie numbers, man. You gotta pump those numbers up.
Reading a thread, not the channel.
That's actually
exactly,
just during this call. He had inbox 0 before the beginning.
Yeah, exactly. I think that's more realistic. I'm not in the office hours channel. I gotta get there. Okay. All right. Doesn't look like any questions here, and I'm really.
Oh, that's my bombardment about the 0.14 Terraform with EKS model.
Yeah. So there's we'll be looking into this next week as we're deploying a new environment with all of that stuff. And if it comes up and hits us, it'll get resolved very quickly. It looks like a known issue. Other Terraform EKS module developers are having the same problem, and functionality or behavior has changed. We don't have the answer yet, other than it's on our radar. And it seems like downgrading to Terraform 0.13 fixes it, but I'm not saying.
Yeah, it worked with 0.13.
That's a stopgap measure. Yeah, so the downside is it's looking like being able to do a single phase plan and apply for bringing up a end-to-end Kubernetes cluster with EKS master and nodes in one module isn't maybe possible anymore, and those need to be decoupled into two phases. Bring up the cluster, bring up the nodes, something like that. We'll keep you posted. It's critical to everything we do. So as soon as we hit it and solve it. That said, anybody else looking at solving it and opens a PR, let us know. Ping me in office hours or Terraform, and we'll review your PR ASAP.
Just time for a quick question.
All right.
About backends. It's just something that I have to deal with regularly where I have to decide, okay, am I putting, for each application, a separate bucket that'll store the TF state, or one bucket for all the different, infrastructure?
It's a good question.
Best practices that.
Yeah, it's a good question, and it depends a little bit what your state backend is. Using S3 is a very painful cold start problem for state backends, and if you want to have more end-to-end automation, you're going to want to reduce that. It also introduces remote state challenges when you want to query it across accounts and boundaries like that, by design, but is a consideration.
Right.
Okay, and so that's S3. And if you're using Terraform Cloud, it's a whole lot easier in general, using it as a state backend, if that fits within your paradigm. Right now, we came from a background of deploying one state backend per AWS account that we deployed. And I like it architecturally, but I hate it from an automation perspective for the aforementioned reasons that it's just really hard to cold start it. So I would consider reducing it to a few buckets based on your compliance requirements. And if you don't have compliance requirements, just use a single bucket. Either way, all your environment stacks, components, etc., yada yada yada, are going to be broken down into different state paths within the bucket and are not shared. And you can use IAM controls to control access to those.
Right.
Always make sure you use versioning with S3 in particular.
Yeah. Or eliminate the calculus and just use our Terraform state backend, which does absolutely everything you need to manage a
Well, and I have been using that, and it's great. But also, I find that like one thing that really bugs me with, and that's not your module per se, it's just the way that Terraform forces you to use S3, is that, so quite often, especially when you want to do updates, you do things locally. So maybe you want to create a new cluster. So you create the Terraform files, everything's local to your machine. Then when you're finally ready, okay, I'm going to move it into S3 so I can share it with my team and people can start using it. At some point, you might want to take that down. Because maybe it's obsolete, it was a test cluster, it was for whatever reason, it's no longer needed, you'll tear everything down. That teardown mechanism, like the way that Terraform has implemented this state backend, it stays in S3 even if you move it locally, right? So you have your local copy, and during that time, there's a copy in S3 that other people could be using unknowingly. Like I looked actually for a Terraform state lock command where I could say, lock this state that's in S3 so that if anyone tries to use it, they know it's busy and they can't do anything. Meanwhile, I can work with it locally again, delete things, whatever.
Yeah.
So
I think it's
I haven't found a good solution even with that AWS state backend.
No, that's true. I mean, just food for thought. I'd say that's a little bit of this layer violation here, that that is part of your foundational infrastructure piece, and therefore that you don't tear down to that level generally because the capability of the tools don't support it, of which that is one minute example, but there's dozens more examples here of trying to tear down and build up across layers. A lot of it has to do with integration secrets and configurations. Amazon accounts can't even be programmatically destroyed without first logging into them and clicking some boxes. And even to log into it and click those boxes, you got to do a password reset. It's just a nightmare. So I think it's a red herring. Yeah. All right.
To be honest about backends, I eventually used a bash script. Please don't tell me anything. A bash script that was fetching the AWS username, so your username, and using that as a key for the bucket, and also as the workspace key prefix, both things. In this way, when you check on S3, you have the username and also which is basically holding the default, and inside the same, they are overlapping, and you have also your workspaces into the same thing. It's a hack, I know, but the point for me was that basically when you start using the backend, even the default is on S3, which is for me a pain in the ass, basically. Sorry, because you need to be very careful if you are testing stuff locally and then enable the backend, because as you know, otherwise you will end up on S3, even your default, and
Yeah.
No, I think it's very dangerous in general. I mean, working locally is very dangerous. I mean, these are resources that are deployed into AWS where any of your developers can reach them. Yet, if the remote state isn't accurate to what, if it doesn't reflect the resources that are actually deployed because you're doing something local, that's very dangerous. And I mean, when we do development stuff, we just do it in completely isolated, either different regions or something, to isolate all of our work. But, anything that's, could be shared or accessed by other people, yeah, I think you really just got to stick to remote state and just, embrace it. TerraGrant, does handle that pretty well. I mean, even just creating the bucket, we follow, a convention that uses the account name, so the bucket name is going to be unique, and the first time you touch anything in TerraGrant, it creates the bucket for you or prompts you to create it. We go in and twiddle, some permissions on there for the fact, but, other than that, it's, that's pretty straightforward, but it's dangerous to do local state things. In fact, I'm trying to reconcile a whole bunch of local state that someone did now. How do I get that into S3 now? It's going to be a huge pain in the neck.
All right. Well, thank you for adding that additional context, Tim. I got to cut us short here. We are over time. I want to thank everyone for participating in the conversation today. We're going to be posting a recording of this session to our YouTube channel, as well as following up with an email later on that you can share with your team. We host these calls every week. We'll as I said, we'll automatically post a recording of this. If you haven't already registered for office hours, go to cloudposse.com/office hours and you'll get a calendar invitation so you don't miss these. Happy to connect with anyone on LinkedIn. Reach out to me there. And remember, Cloud Posse is hiring. So go to jobs.cloudposse.com if you're looking for contract opportunities working with Terraform. Talk to you soon. Same time, same place.
Thank you, everyone. Thank you. Bye.
Thank you.